Here we are graphing one cycle of a generalized sine wave. So normally our sine waves starts at 0, the origin, and a period of 2 pi. We're back to the origin, we're back to 0, the baseline. Halfway in between, we're at 0. Halfway between there, pi halves, it's up at the amplitude of 1. And then halfway in between the other spots, 3 pi halves, it's down at amplitude. So at -1. That's our normal information about our sine wave. We have some changes to this one. Starting with this number, we will start down, whereas normally the sine goes up. This one's going to start going down because of the minus. And then also the amplitude, the absolute value of that coefficient is 2/3. We have our period is the normal period for sine, 2 pi, divided by the coefficient of x called omega. In this case it's 4. So that simplifies to be pi halves. We have the phase shift. The phase shift is what makes the inside of the trig function 0. So if we solve for x, this would be x equals pi eighths. You could also factor out this minus 4 and see it as x minus pi eighths, but this is an easy way to do it. And then vertical shift. This is the constant function, or the constant of the function, it's 1. Now because the sine and cosine waves, and in fact all the trig functions, are based on the unit circle, the values, if you divide the period by 4 quadrants in a unit circle, or multiply by 1/4, you can get a really nice option for the tick marks, how you're going to put the tick marks down on the x-axis. So comparing the phase shift and 1/4 of the period, the smaller of these is how I set up the tick marks. I'm going to use just pi eighths since they're both the same. So I'm going to have each of these tick marks be pi eighths distance between. So this is pi eighths. All right. Now I think we're essentially ready to go. The vertical shift of 1, the amplitude is 2/3, so I would like to have these vertical bars be like 1/3 maybe, and so up 3 of these, I'm going to call this 1. This is our baseline. This is the vertical shift. So normally the baseline is at 0. Ours is up. Normally the sine function starts at the baseline. We are right pi eighths, so we're starting right here. We're now set to begin this process of getting the other points on the sine wave. This is where it starts. So a period. The period is pi halves. If I look at that in terms of eighths, this is 4 pi eighths. So the period is 4 tick marks to the right. 1, 2, 3, 4. That's going to be the period. Half of that is still at the baseline. Halfway between these two, it'll be at amplitude. And since we started down, it's going to be in between these first two. It's going to be down 2/3, which these are thirds lines, so it's going to be to here. And then the other one will be up 2/3. We have a really nice set of points to graph the sine wave. If we needed to isolate a certain point, like if someone needed to label that point, we could do that. pi eighths, 2, 3, 4 pi eighths, which would reduce to pi halves, and up 1, 2, 3, 4, 5 thirds. Each of these lines is a third. You could do that with any point you needed to. You could continue this 4 tick marks to the right. 1, 2, 3, 4. Halfway between, halfway between, halfway between. This halves technique is a really nice way to generate more and more points. So we have one cycle of the given function that I drew. I drew a second cycle as well just to continue on. The period is pi halves. Another common question is the frequency, which is just 1 over the period. And so in this case it would be 1 over the pi halves. It would be 2 over pi. Some common questions that are asked. I hope this helps.